Hello, hello. 1.8 applications and models of trig. So, first question, completing a triangle. When you're completing a right triangle, first thing you should always notice is that this picture right here is always the same picture. That means C is always your 90 degrees. So the capital letters are your angles and the lowercase letters are your sides. And once you know your angle, across from that is going to be their lowercase letter. So capital A is right here, across from that is little a. Capital B is right here, across from that is little b. Now, when you're doing this, I want you to figure out the three remaining parts that are missing. So first thing I see is that in a right triangle, which you should know, all the angles in a triangle add up to 180. So we could do 90 plus, because that's our C, B plus our A value here is 34.2 and have that be equal to 180. And that would give you B is 55.8 degrees. Now that we have all three angles besides 90, we're not going to be using 90. We can use either angle A or angle B for our next two sides. So I'm going to look for A next. Now if I look for A, to make my life easier, I'm going to try to use this angle because that will give my opposite. I have my opposite, or I'm looking for my opposite, and I have my adjacent. This is where you have to know your SOHCAHTOA. So I'm going to use tan of my angle is equal to my opposite, which is A, over my adjacent, which is 19.4. And the reason why I chose that angle instead of angle B is because now to get rid of that division, I'm going to multiply that over. So 19.4 times tan 34.2 will be equal to A. So A is equal to 13.18. At this point, it's kind of up to you of what you might want to do. You can either use the fact that a squared plus b squared is equal to c squared. That is an option, and sometimes I use that option. Or I can also use this side length that was given and looking for this side length with this angle, or I could use that angle. It all kind of depends. I'm going to use this angle, so that means I'm going to be using cosine. So cosine of my angle, which is 34.2, is equal to my adjacent, which is 19.4, over C. Now the difference here, I would have to multiply my C over and then divide. So in order to figure out my C value, I have to do 19.4 divided by 34.2. And my C value is 23.46. So that's one type of question for the models. Another type of question is when I give you word problems and you have to solve them. So safety regulation states that the maximum angle of elevation for a rescue ladder is 72 degrees. So if I draw out a picture, this is my angle of elevation. That's 72 degrees right there. Fire department's longest, that should say longest ladder is 110 feet. What is the maximum rescue height? So that's saying this ladder is 110 feet. It's asking how high can you actually get with that ladder. So once you set up the picture, then this is using SOHCAHTOA. So I'm looking for my opposite. I have my hypotenuse. So I have sine of my angle is equal to x over 110. And I solve that. And the max height here would be 104.6. It doesn't say where to round to, so I'm going to say 62 feet. And how did I know it was feet? Because the ladder is in feet. So I want you to pause the video, and for example 3, I want you to try to set up a picture of this first. This one's a little bit more confusing, but try to set up the picture first before I do. So this is what the picture is. It's actually a picture within the picture. So it's asking for just this height. So if I notice that, I could take this whole pink side, because that was my 53, because you're looking higher when you're doing that, because that's the top, and comparing it to the bottom, which is 35 degrees angle of elevation. So if I set up my equation for this larger angle, where you're looking at the top of the smokestack, I'm going to label this x, this value right here. So that's right here is going to be tangent of my angle is equal to my opposite over my adjacent. And then I'm going to make sure, I'm going to write it out like this. And I'm going to subtract the equation of my smaller when I looked at the bottom of the smokestack, which is tangent of my angle is equal to my opposite. Notice how I did not put the same variable there, but it doesn't really matter because if I were to solve both of these, because this is going to be some number, that length, so this would be 200 times tan of 53, And again, I'm looking for that unknown. So subtract this other length, which is 200 of tan of 35. And I'm going to put it in exactly like that into my calculator. So this is going to be equal to 125 point, I'm going to say 37. If I look, how far away did I walk? Feet. That's smokestack. Question 4, again, I want you to try to set up the picture before I do. So pause and try to set up the picture. So this is kind of like what my picture looks like so far. So it's going to be 20 meters long, 12 meters wide. We don't actually need this 12 meters wide because when you're talking about width, when you're walking the width of a pool, typically that's going to be the same depth, so 1.3 meters. So this is saying from my shallow end to my deepest end. Now, when I'm looking at this, I'm asking for, remember when it's saying the angle of depression, which this is what it's saying about, you look at that length that is horizontal, so that length right here, and that length from looking down. So this is the angle I'm looking at. So notice how I'm cutting that off. So if this whole length right here is 4 meters, that means this length right here is 1.3. So to figure out what this length, I would do 4 minus 1.3. I'm going to get 2.7 meters. So now if I look, this length is still 20. So if I want to look for that angle, I have my opposite and my adjacent. So that's going to be tan of my angle is equal to my opposite over my adjacent. So in order to get rid of tan, you have to do the arc or inverse of 2.7 over 20. And if you put that into your calculator, you would roughly get 7.69 degrees is the angle of depression. So first, before we get into the next problem, we have trigonometry bearings. When we're talking about trigonometry bearings, we are still thinking of our x-coordinate, except now we have north, east, south, west. And there's a song that my daughter's singing, never eat soggy waffles. Never do it. That's gross. Never eat them. So we still have our terminal side. So let's say this terminal side, except now when we say an angle, we start with our north to south. Typically when we say an angle, we start with our north, whatever side you're touching. So in this case, I'm touching my north side to this terminal side, and it's in between northeast. This angle, let's say if it was 35 degrees, this would be north 35 degrees east. That's how that angle is represented. Now let's say if I did it this way, if I started here and I measured that angle right there. Well, first I would have to figure what that is. Remember in a 90 degrees, or north and east would create a 90 degrees right there. So this angle right here is 55 degrees. And because I'm starting on the east side, this angle in the blue would be east 55 degrees north. So notice how they're not the exact same depending on what bearing you use first. But a lot of times we will be using the south and north first. If I said this angle right here, because I'm starting off on the south, north and south line, this would be south, and let's say that this is going to be 52 degrees west, because it's in between south and west, and I'm starting on the south end. So that's what our bearings are telling us. So this pictures are actually already given to us. So while you're looking at the picture and reading this, we're starting here. This is where the port is. We're leaving at noon. It's telling us that we're going straight west. Due west means straight west. So it's straight west, 20 knots, or not. I'm not going to be able to say that correctly. Nautical miles, so NM. So knots are nautical miles. So how fast you would travel by ship. So in this case, 20. And because in between at noon and 2, that's 2 hours, and you're moving these per hour, that's why this length right here is 40 nautical miles. So knots, the distance, nautical miles. And then it's saying it switches the direction to north 54 west. So notice how this dotted line is here, because that's our north. So we have to start with this. This angle right here is 54 degrees. And then it switched that and did that for 1 hour, because that was the remaining hour. The question is asking this length right here. How far is this from the original place that we started from? So how are we going to figure that out? If we need to figure that out, we need to figure out 2 different lengths. Our main objective is to try to figure out what this angle is right here. Because if you look, we have this 90-degree triangle here. We also have a 90-degree triangle here. That's not going to help us. We also have this 90-degree triangle here. This one is going to help us right now because we already know that this was travel in 1 hour. So we know that this is 20 nautical miles. So using this triangle and the fact that we have this angle right here, we can figure out this other angle inside this small triangle because this is on a linear line, on a line. So all of these add up to 180. So this angle right here is 36. So if I want to figure out what B and D are, I can say sine of 36 is equal to my opposite over my hypotenuse. I can also say cosine of my angle 36 is equal to D over my hypotenuse. So I can solve for both of those equations by multiplying my 20 over, and I would get that B is equal to about 11.76 and D is equal to 16.18. So now if I look at my bigger picture, I have this length, which is 11.76, and I have this length. So I can figure out this whole length by adding 40 to it. So if I do 40 plus 16, this would give me 56.18, and I have my 11.76. So now in that right triangle, what we can do is a squared plus b squared equals c squared. So again, we're not using a, b, and c, so this would be plus to figure out what our actual c length is. So pause the video and figure that out. And you would get roughly about 57 well, this would be 40 nautical miles away. And last but not least, we have harmonic motion. So what is harmonic motion? Basically, harmonic motion is basically when you're moving something, you're oscillating, and it's moving back and forth. So if we look at this picture, let's say if there was a ball at the end of this spring, and then the maximum distance it can go is this 10 centimeters. So if you pull it down, if you let go, this is going to retract, and then it's going to bounce, and then it's going to bounce, and then it's going to bounce, and it's going to have this bouncing motion, and so it has an even displacement. And when we have this bouncing, another thing that we've been dealing with is like a curve of some sort, like the maximum to minimum, but it goes until it gets to its equilibrium. And that's where we have our simple harmonic motion. When we know the distance from the origin and the t time, we have these equations right here. So you should highlight that. So this first question, write the equation for the simple harmonic motion of a ball described above, where the period is 4 seconds. So when we have equilibrium, that means our distance is going to be 0 and our time is going to be 0. So we're going to use this equation, D equals A sine fancy W, that's my fancy W, sorry, and T. Now that A stands for our amplitude. So now if I'm looking back at this picture, because this is the picture we're looking at, our amplitude is going to be 10 because that's going to be the distance, maximum and minimum distance. So I know my A value, the absolute value of that is going to be 10 right there. It's also telling us that the period is 4 seconds. So we know that the period is 2 pi divided by, I'm going to use my fancy W, would be equal to 4. So we're going to use that to figure out our fence. So if we multiply this over, we get 2 pi is going to be equal to 4. W divided by 4, we know that W then is going to be equal to pi over 2 because I simplified that fraction. So this is pi over 2t, because that's where that fancy W comes into play, is equal to our distance. Now we can use that now to find our frequency. It's always asking for, not always, but for this question, it's asking for a frequency. So our fancy W is pi over 2 divided by 2 pi. That's the same thing as multiplying by 1 over 2 pi. So if I simplify that, the pi's cancel out, that'd be 1/4 frequency. So what we found is that we have a 1/4 cycle per second. Frequency is how often it actually occurs. So 1/4 of the cycle per second is what we just found. So now for example 7, it gives us D, it gives us our equation. So first of all, we want to find our maximum displacement. Sorry, there should have been a 6 written there. So when I'm talking about maximum displacement, this is actually talking about our amplitude. Use a different color. So this is saying, what's our amplitude? So A, my amplitude, my absolute value of 6 will be 6. That's my amplitude, my maximum displacement, how far away from the equilibrium it will be. For B, our frequency is taking that equation right up here, our fancy W, which our fancy W is always times our time, so this is 3 pi over 4 divided by 2 pi, so 3 pi over 4 divided by 2 pi. Again, that's the same thing as multiplying by 2, or multiplying by pi 1 over 2 pi. So if you simplify that, this will be 3/8 cycle per time. We don't really know the time here. So cycle per time. We don't know the units for that one. For C, it says what if, or find the value of D, if our time is equal to 4. So if we use this equation, 6 cosine 3 pi over 4 times 4, and then we have to solve that. That's our T for time. So I have 6 times cosine of 3 pi. Now, we can find a coterminal angle to that. So 6 cosine, I would subtract 2 pi of pi. Remember, cosine at pi, cosine is always going to be our x value. So when we're looking at pi, our x value is equal to -1. You can look back at your unit circle for that. So this is saying plug -1 in for that equation. So this would be equal to -6. Which was equal to our D value. And last but not least, says find the least positive value for T for which D is equal to 0. So if we said that this equation is equal to 0, so same type of thing that we have going on here. Cosine 3 pi over 4 T. Now if I'm solving for this, I'm going to divide over by 6. So we're just looking for where 0 is equal to our cosine 3 pi 4 times T. Now what we can do from here is find when cosine is 0. So if you look at your unit circle, or if you know your unit circle, the places where cosine is 0 is our pi over 2. I'm going to write them all pi over 2. We have 3 pi over 2. We have 5 pi over 2. And then it just keeps rotating. So these are all equal to our 3 pi over 4t. And we're looking for that t. Okay, so if I'm going to solve this, I only want to find the least positive. So really I'm going to focus on just this because I'm looking for my least. Because again, it's oscillating. It goes back and forth and back and forth. So if I want to solve for t, this is being multiplied. I can multiply pi over 2 times 4 over 3 pi. And if I multiply that across, I would get 2/3. So 2/3 is our least positive value for when D is equal to 0. I know, that's a lot. We'll get over it in class. Have a wonderful day.